The question is, check the injectivity and surjectivity of the following function. That means we have to check whether it is 1, 1 and onto. Okay. First question is f from n to n given by f of x equal to x square. So we are going to check whether it is 1, 1 or not. So what will the condition f of x1 equal to f of x2? That means x1 square equal to x2 square. You will be having a tendency to write as a next step x1 equal to x2 by cancelling the square. That is not a correct step. What we have to do here is take x2 square to the left side. So we are getting x1 square minus x2 square is equal to 0. Now the left side is of the form a square minus b square. So factorize it. A minus b, that is x1 minus x2 into x1 plus x2 is equal to 0. Since the product of two terms equal to 0, that must imply either x1 minus x2 equal to 0 or x1 plus x2 equal to 0. Okay. What are x1 and x2? x1 and x2 are natural numbers, 1, 2, 3, 4, etc. So no two natural number give the sum as 0. No two natural number give the sum as 0. So this is not possible. So the only possibility is x1 minus x2 equal to 0, which implies x1 is equal to x2. So what we took is f of x1 equal to x2, and what we got is x1 equal to x2, which implies f is 1, 1. Okay, again we have to check whether it is onto or not. To check whether it is onto, what we told us, we will take the function f of x equal to x square. Instead of f of x, we will write y. Y is equal to x square. From this equation, we will calculate x. X is equal to plus or minus square root of y. What is y? Y is an element of the second set, which is a natural number. Suppose you are taking the value of y as 3. So this will be equal to plus or minus root 3, isn't it? Root 3 is not a natural number. Okay. If I am taking the value of y as 9, of course plus or minus root 9 will give you the value 3. Root 9 is a perfect square. So you are getting the square root. One square root as 3, which is a natural number. But there are cases in which the number is not square root. Even the positive square root is not a natural number. That means it does not belongs to n. Okay. Therefore, what is the conclusion? F is not onto. So the question was to check whether it is injective and surjective. So we are coming to the conclusion that it is injective but not surjective. Okay. Moving to the second question. F from Z to Z given by f of x equal to x square. The function is defined as the same. The only difference is in the domain and codomain. For the first part, the domain and codomain was natural numbers, and here it is given as integers. So we will check. We will start with f of x1 equal to f of x2, which implies x1 square is equal to x2 square. Don't cancel the square and write as x1 equal to x2. Take it to the left side. So x1 square minus x2 square is equal to 0. So while factorizing, we are getting x1 minus x2 into x1 plus x2 is equal to 0. So x1 and x2 are element of integers, isn't it? If these two term product is equal to 0 implies either x1 minus x2 equal to 0 or x1 plus x2 equal to 0. This is possible here. Why? Because x1 and x2 are integers. If I am taking x1 as 2 and x2 as minus 2, 2 plus minus 2 gives the value 0, isn't it? So either this can happen or this can happen. If this is there, we are getting x1 equal to x2. We will come to the conclusion that it is 1, 1. But this also holds. That means x1 is equal to minus x2, which implies f is not onto. F is not 1, 1. Clear? In this case, x1 plus x2 will not be equal to 0. Why? Because x1 and x2 are positive numbers, 1, 2, 3, 4, etc. So no 2 in numbers sum will give you the value 0. But in this case, x1 and x2 are numbers from Z. That means they are integers. Integers means positive numbers are there, negative numbers are there. So if I am taking x1 as 2 and x2 as minus 2, obviously their sum is 0. That means x1 plus x2 equal to 0 is possible, which implies x1 equal to minus 2. Either x1 can be equal to minus 2 or x1 equal to x2. We need to get the condition x1 equal to x2 only. Here, since we are getting these two conditions, we are coming to the conclusion that f is not 1, 1. Okay. Again we have to check whether f is own to or not. So same way we will take the function f of x equal to x square. We will replace by y is equal to x square. So we are getting x as here also plus or minus square root of y. Again what about root to y? Will it be an integer always? No. There are cases, suppose y is taking the value 5. Then what will be x? X will be equal to plus or minus square root of 5, isn't it? Which is not an element of Z. So what is the conclusion? F is not own to. Okay. The third question, third function, there is only difference in the domain and the codomain is from R to R, real numbers to real numbers given by f of x equal to x square. Here also we will check f of x, whether it is 1, 1. Take f of x1 equal to f of x2. That means x1 square equal to x2 square. We are already dealt with. So we are getting the equation as x1 into x2, x1 minus x2 into x1 plus x2 equal to 0, which implies either x1 minus x2 equal to 0 or x1 plus x2 equal to 0. If this is there, okay, we are getting x1 equal to 0. But here, this is also possible, isn't it? x1 plus x2 can also be equal to 0. Why you know? x1 and x2 are from real numbers R. Okay, so here also if I am taking x1 as minus 2 and x2 as 2, minus 2 plus 2 gives you the value 0. So either x1 will be equal to x2 or x1 can be equal to minus x2, which implies f is not 1, 1. If to be 1, 1, we have to get only the condition x1 equal to x2. So here we are getting both the condition. Either x1 can be equal to x2 from this equation. Otherwise x1 can be equal to minus x2 from this equation. So we are coming to the conclusion that f is not 1, 1. That is f is not injective. What about the surjectivity? Same case, we will take f of x equal to x square, replace by y is equal to x square, therefore x is equal to plus or minus root of 1. Same is the case, isn't it? Root of y. Suppose I am taking the value of y as 9, let it be 10. So what we get is x is equal to plus or minus root of 10. Root of 10 is not an element of real number. Okay, so what does it imply? F is not onto. That is f is not surjective. So as the function definition differ, surjectivity and injectivity changes. When it is from n to n, it was 1, 1 but not onto. When it is from z to z, it is not 1, 1, not onto. When it is from z r to r also, it is not 1, 1 and not onto.